Okay, so class, Assalamualaikum and good evening. Okay, so for today's class or for this week punya class, we will enter the new chapter which is integration. Okay, so it's similar like the like differentiation. We have two, analytical and also differentiation, right? Analytical and also numerical. Okay, so same goes to integration. We also have analytical and also numerical. So for the numerical, I will proceed next week. So for this week, we will learn for the analytical integration. So the first thing first, what is integration actually? Okay, actually integration is something that relate to the differentiation, right? So as we know that integration is the antiderivative, maksudnya is a reverse to the differentiation. Okay, it's a reverse to the differentiation. Okay, so for this week, the topics that we will cover is we will learn the method that we will use to solve integration. Okay, for analytical because for numerical punya topic which is next week is a different method. Dia ada method lain pula. Okay, so bear in your mind that integration they have two. If we just mention integration, maksudnya if you have a question that said solve this one blah 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 by using integration. Okay, so means that it's just integration. It's a analytical. But if the question mention numerical blah blah, so it's a numerical lah. Okay, but okay, so okay, we leave it that one first. We proceed with the method. Okay, so what we call, okay, so in this chapter integration of analytical ni, you will learn a few methods. Okay, a few methods. So I just list down first. So the first method is by using substitution. Okay, by using integration by substitution. Okay, by substitution. And the number two is integration by using by parts. Okay, by using by parts. And then for number three, we will learn integration by using tabular method. Okay, alright. So these three, okay. Suppose there are four method in maths. Okay, dalam maths lah. Do have four. The last one is by partial fraction. Okay, alright. So but for our syllabus mostly we will touch on these three. Okay, substitution by part and the word. So I will focus on these three first. Okay, alright. Okay, so okay, we start with the first one which is a substitution. Saya ingat lah. Substitution. Okay, so actually the purpose of the substitution, but the purpose by we are using substitution is to transform a complicated integral into an expression of a basic integrals. Okay, selalu macam you dapat soalan you rasa complicated. So what's defined by complicated here? It's something that you have a cos in exponential in one term macam tu lah, and then you have a power, you have a square root, so that things that make it us feel like it's complex, right? So that's one the meaning of the complicated integral lah. So you will reduce that one into a basic integral. And the basic integral means something like a simple one, x squared, x cubed, and something like that lah. Okay, so they have a few steps lah, okay, that you need to follow. So I will explain the steps in the example. Okay, so now we go to the what we call, okay, so in the steps, okay, you should choose appropriate u. Maksudnya dalam steps tu nanti you kena pilih u. Okay, dia tak ada formula yang spesifik. For substitution tak ada formula. It just you let u for the specific function. Maksudnya you kena pilih u yang betul. But how do we know that we perform a correct substitution? Macam kita tak tahu yang kita punya substitution tu betul. So what we call, usually the u yang you pilih tu, it depends on the higher order. Maksud ataupun you pilih something that using the, it's a lawn pad. Kalau if you still remember, it's a lawn pad. Saya tak sure you over this term or not. Okay, lawn pad. So lawn stand for lawn, log. Okay, it's the same. P is stand for the polynomial. E is stand for exponential, and T is stand for trigonometry. So the what we call the priority is start from ln PET. Okay, alright. Okay, alright. So then actually how we know? Okay, back to the statement just now. How we know that we perform a correct substitution? So actually you upon the performing the substitution, once you do it the substitution, x. Okay, we use a variable x right usually. So x in the integral must disappear, and only the variable left should be u. Okay, tadi kita dah let u kan? You still remember that what I said? We will let u. We will choose a function and then let as u lah. So I repeat again. Okay, you point the performing the substitution. X in the integral must disappear, and only the variable left should be u. Okay, must u je. Tak ada. I mean, they have no s there. But if there are x left, if they have x, okay, kalau ada x lagi, it might be we chose the wrong substitution. Okay, get it what I mean? So they have no specific way to know whether our substitution is correct or not. But by performing that one, you point the performing, you will see that one. Kalau you tak disappear, your x is not disappear, means that you have do the wrong substitution. Okay, alright. So that's the important part lah for the substitution. Okay, I will show you the example. Okay, I will show the example of the substitution. So this example asks you to solve by using substitution. Okay. Let's say you have what you call okay, integrate sin x cos 2dx. Okay, now class, see carefully. We have sin x, we have cos square x. So you can see, right, this is complex, right? It's something that you feel, oh, why? I mean, they have two functions in one term. They have a power of cos and so on. So it's clearly that we feel that it's complex. So we will solve this one by using substitution. Okay, by using substitution. So what we do? You need to let u. Okay, you need to let u equal to, okay, which one that you need to let u? Of course, compare sin x and cos square x. Which one that you feel that is more complex? Of course, you can know. Of course, we see that cos square x, right? Cos x, because they have a power. Okay, they have power here. But for the let u now, you just take it cos x. Okay, the power you remain there. Maksudnya the power we ignore. We just take it the function. Okay, you take it the function means the term that cos x lah, without power. Okay, without power. Okay, so you have u equal to cos x. So now what we do next? Okay, we differentiate u. Okay, this is u, right? With respect to x. So differentiate cos, what we have? Negative. Differentiate cos, sin, cos, negative sin. Apa? Negative sin x. Okay, so you have negative sin x. Okay, betul tak? Okay, so you differentiate cos, differentiate. Even though we do it for integration now, but when you differentiate cos, you will get negative sin x. Okay, so what we do next is you will bring dx. Okay, bawa naik atas tu x tu. Okay, you bring this dx. So means that you have du equal to negative sin x dx. Okay. Okay, then what next? So now, alright. So now, what we do next is, okay, you refer to your question back. Okay. So So can you see that inside this step or inside this equation just now, you have sin x and ds or not? Okay, by referring to these two. Okay, because of du now is negative sin x ds. So is it you have sin x ds or not? Okay, kalau you, okay, yeah, actually they have sin x, they have ds, but it's not together, right? So actually you can just rearrange. Tak ada masalah pun, you susun balik. Because of this is multiplication. Okay, cos and sin is multiply. So means that you can just rearrange the what we call the sequence. Tak ada masalah. The meaning is still the same. Okay, so you can see that they have sin x ds here. So you already have also sin x ds here. So but they have a negative, right? So means that the negative here means it's somewhere here lah. It's somewhere here. Maksudnya, okay, I erase this negative, I put it here. So means that negative du is equal to sin x ds. So what we do next is you just replace this one. Okay, so cos square x, okay, sin x ds is no longer sin x ds. It will be negative du. Okay, negative du. Okay, I just replace. I don't want x because, okay, like I said just now, we want to disappear x. So we do it slowly, we will do it one by one. So we replace all the sin x ds here with the negative du. So the next thing here, you can see that they still have x right here, right? But your u. So your u is cos x. So means that the cos x, okay, for those that doesn't know, cos square x actually is also equal to cos x power 2. This power 2 is belong to cos x, the whole cos x. Okay, maksudnya you boleh take out lah. These two you can take out and then you write in outside the bracket. Okay, so okay, kalau you feel that you can easy tak nampak kan, so I write here like this. Okay, so means that it's a cos x power 2. Okay, so your u equal to cos x. So means that inside here you can replace by u. What? U power 2. Okay, u power 2. Because they have 2 right here, power 2. So make sure you bring this power. For this part, you just take it the cos x without power. But for this one, you need to bring what we have here, what we have in the original equation. Okay, so now you have u squared times with negative du, and then this negative I want to put it outside here. Okay, because it's a multiply, right? It's a darab, so you can bring that negative outside. And then u square du. So now you can easily integrate, is it? I hope that you know that we can integrate this one right now compared to this one. This one is the original one just now, right? So you can see that it's complex. It's complex. Then you derive it, you substitute and so on, and you already disappear your x. So means that you what we call, you do the correct substitution. This one you perform the correct substitution lah, because the x is no longer there. You just left with a u's. Okay, so now integrate u square. So you have u power. You have u power 3, right? Tu tak power tambah kan? And then divide by 3. Okay, we divide by 3. Okay, so the integration. So we divide, and then since this is the integral definite, so means that you need to plus c lah. And then don't forget your negative outside here. So negative u cube over 3. But please don't stop here. This is not the final answer yet. What we need to do now? What you should do now actually? Okay, so if you refer back to your original equation is in variable x, right? X. So you cannot leave your answer in u. Cannot, tak boleh. So what we do is just replace back your u. So your u is cos x. So then this is your final answer. Okay, right? So you just replace back your u. Okay, your u ni you gantikan balik sebab your final answer must be in term of x lah. Your final answer must be in term of variable x, bukan u. Okay, so get it what I mean? Okay, right. So this is what we call the example of the substitution. So they have more other example on the substitution. You can refer to the slides. So yeah, you can refer to the slide. Okay, so in the next video I will explain on how to solve integration by pi. Okay, integration by pi. Okay, for this one actually you need to do a lot of examples. So you can refer to the slide, or if you feel that the slide also tak membantu, okay, you can find the other slide in the Google. Boleh, you search je. Okay, insyaAllah you akan jumpa. Okay, you akan jumpa example, a lot of example in what we call in Google, in internet. Okay, so I will see you. I will proceed the next title, subtopic, which is integration by pi in the next video. Okay.